Hey, welcome back to the ENM2600 playlist. I'm Ben Hardless, and today I'm going to help you out with this pretty hairy loci problem. So hopefully you can see the one that I've got on the screen here, and I'm just going to work through it systematically. First thing you got to know is replace the z's with x plus jy. Z is a complex number, has a real component and an imaginary component. We represent that as x being the real component and jy being the imaginary component. So all we're going to do is, once I get my pen set up, is write this out, replacing the z's with x plus jy. Now this bit on the bottom of the fraction is just a magnitude, right? So absolute value, 4j plus 3. The magnitude of the complex number is just found by squaring the real component, squaring the imaginary component, and then taking the square root. And I'm going to try and draw that a little bit straighter. There we go. And on the right side, we'll just distribute the negative. So we've got 7 plus. Oh, no, we don't. We've got a conjugate there, so we've got to watch out for that. With the conjugates, we're just going to change the sign of the complex of the imaginary component. So where it's minus 4j in there, and there's a conjugate around that for that whole complex number, we just change the direction of the imaginary component. So where it's negative 4, it now becomes 4. 4j plus 2. The real component, its sign, does not change, okay? Very important. We've got another conjugate to deal with over here, and we'll do the same thing. But first, I'm just going to collect a few things together. What we could probably do first is just distribute this negative over here on the right-hand side. So what we got to do there is, if I can erase precisely enough, it's minus 4j. We've also got to distribute it to this 2, don't we? Okay, awesome. Well, straight away you can hopefully see that that and that are going to cancel, and we can probably get rid of that 2 by minusing 2 over here. All right, so now this is pretty easy on the right hand side. We've got 7 minus 2, so that's going to be 7 minus 4, which is 3. So let's just replace that with 3. Now 3 squared plus 4 squared, that's 9 plus 16, which is 25, right? 25. So a square root of 25 is 5. 5 5's 25. Hopefully you did that in your head. If not, problem. All right, so all this stuff over here is gone, and we've simplified it a fair bit just like that. How about we take this 5 and we multiply both sides by 5, and that'll get rid of the fraction. So that just becomes this. Now 5 by 3 is 15, so we've got a 15 here now, and I'll move all this down so it looks a little bit neater. I'm sorry I'm not doing it in lines. It just seems like pretty easy simplifications so far, so that's all I'm doing. A really good thing that I recommend you do is just collecting the real and imaginary components. So what do I mean by that? I mean, before you do anything further, it's a good idea to say, well, this set of parentheses on the left-hand side, let's just go, okay, what's the real components that doesn't have a j with it? The x. So you get x plus j. And then you collect all of the imaginary components. So we've got a y and a minus 2. So it's j, y, minus 2, right? All you're doing is factoring out the j, is what I'm saying. Now, this becomes very important when you're dealing with loci that represent a circle. So you might get an equation like this, and it's going to end up representing like a line. You're going to get a Cartesian equation for a line or a ray or an ellipse or a circle, something like that. So what you've got to do is try and get it in a Cartesian form that is familiar to you. That's kind of the whole point of this exercise. Now, we won't deal with the conjugate just yet. I'll just show you i.e. that means that is, so I'm just next line of my working. Again, real component is just an x plus a j, y minus 2. Oh, isn't that lovely? It's just it's the same as on the other side. However, we do have a conjugate here. Do not forget the conjugate. It's super important. Okay, next line of our working is going to be dealing with the conjugate, I believe. So actually, we'll do that on the same line. The best thing to do with the conjugate is you just get rid of it and then change the sign on the imaginary component. That's it. All it's doing is reversing the direction of the imaginary component. So just like that, we've simplified our expression a bit more, our equation. Now we've got to multiply this out. So let's just go systematically. So we'll get an x squared minus j x y minus 2. So that's this x on the left and this j y minus 2 on the right hand side with the minus, of course. And so now that one's done. And then it's going to be plus j x y minus 2. That's this x here with this guy here, right? J y minus 2. And cool, they're going to cancel out. That's pretty handy, isn't it? And now we've just got to get these right-hand terms in both of those sets of parentheses together, which is going to be minus j squared y minus 2 squared. And all of that is equal to 15. So the cool thing about a j squared, if you recall that j is equal to square root of -1, if you find, so therefore, this is a nice little symbol, you should use it in your working in your exams, right? Therefore j squared is equal to root -1 times root -1, which is equal to -1. So wherever you see a positive j squared, you just replace it with a -1. So in this case, j squared, you replace it with a -1 minus -1. You can just change the sign on this, can't you? This can just become a plus. That's pretty handy. So I'll just move this over so it's a bit neater. Okay, now remember we said that this is going to cancel. We've got a minus blah 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 and a positive blah blah blah. So those are going to cancel out. And now we've got some kind of interesting thing going on here. We've got x squared plus y minus 2 all squared is equal to 15. Now, what is this an equation for? This is a Cartesian equation, right? There's no imaginary components. We've got x terms, we've got y terms, and it's all nice and neatly collected like this. And hopefully you're seeing that the standard equation of a circle, if we just make a little note off to the right hand side here, let's go change my color. All right, so a circle's standard equation, and I'll just make sure you know this is a note, it's not actually to do with this, is going to be x plus a squared plus y plus b squared is equal to the radius squared. Now, if we compare that to what we've got over here, we actually are pretty close to that. Like, if our a we say is 0, then that's just x squared. If, in our case, our b is -2, and our r squared is 15. So what we're saying is we have a circle, right? So this is the equation of a circle, and you're going to need to write this down when you actually solve it. You've got to say what it is. Don't forget to actually answer the question. Circle with radius root 15, right? Because this bit over here is radius squared, so obviously radius is the square root of what's on the right hand side. And center at, now where's the center? So what you do is, if the term inside the parentheses of in the circle, an equation for a circle, is 0, it's just going to be, well, okay, it's centered at x is equal to 0. So we'll just give it some coordinates. X is equal to 0. And in this case, what makes this y minus 2, what will make that a 0? It is when y is equal to positive 2. So it is positive 2. So the center of the circle is at 0, 2. Now, I'm just going to quickly draw a plot of that for you, so I'll pause the recording, be back in a jiffy. Okay, hopefully I've got you back and you can see the plot that I've put here. It's pretty straightforward, really. Here's the center point just there, so that's 0, 2, as you can see, and where this is the x and this is the y. The radius here is root 15, and that's the kind of plot that you should get at the end. Hopefully this has been helpful for you. The main points to remember are replace the z's with x plus jy. The next thing is to collect the real and imaginary terms. The next thing is, when you've got a conjugate, you just need to change the signs of the imaginary terms. And the last thing is, when you've got a j squared, you replace that with a -1. Anyway, I hope this has been helpful for you, and I look forward to seeing you in the next video. Cheers for your time. Bye.